Alright, does it sound okay when I talk? Guys, if you can just give me a second.
Yeah, of course.
Hello, hello, hello. I suppose I can.
Oh,
Hello, hello, hello.
it's coming through.
Okay, it's come through.
You might want to turn it up again a little bit.
Right, gotcha. This is kind of peaking. I'm not sure if it's getting the audio from the right place. I don't know. We'll figure it out as we go
Where
along.
else could I get it from?
I don't know. Places. This is kind of peaking. I'm not sure if it's getting the audio from the right place.
Oh, that sounded pretty good.
We'll figure it out as we go along. Okay, sorry about that delay. We had some technical issues for reasons. Software, right? Okay, so final lecture. So what happens here is, of course, you guys finish up your projects, and then you have your demo day, and you go to the Camby at demo day, drink a huge amount of alcohol, and then come in the next morning, having regretted all of your decisions, your brain feeling like it wants to climb out of your skull. Or you could like drink a moderate amount. That's also a possibility. Haven't seen it done, but apparently it's possible.
We have class at 9 on Friday or 11?
No, it's like 11. Yeah. But you're gonna wake up being like, was it at 9? I should just get it at 9, and then you'll be here.
No.
So yeah, that is. Yeah, so that covers the course itself. But then, of course, there's a day after the course, and days after that. So it's really easy to kind of focus on the, there's this Latin term, cursus honorum, the course of honors. And it meant like, it was this sort of like path that you would follow in terms of like the things you were supposed to do with your life, and the ways that you were supposed to rise through government and that sort of thing, right? And it's so easy to think of school as being this sort of like, and kind of any trade is, it's sort of marketed in school like it's like this cursus honorum where it's like you just go through the things and then you get the what's it, right? And the truth is that I can't tell you what happens next for you. I can tell you about my experience. I can tell you about the experiences I've seen. I can tell you about my experience from the inside and those ones from the outside. So you know. Little column A, little column B. But what is going to happen next is that either you are going to get a job or you're not going to get a job. So you'll probably get a job. We have a good rate. But yeah, so there's going to be that time where maybe you're looking for a job. I don't even know if you're looking for a job or if you're like, I just want to go back to different things. But so let's say you're looking for a job. So you're going to be doing the job searching, and you're going to go through interviews, you're going to kill it, you're going to get that job. So, at that point, are you done? Did you get what you came for? Is that all? No, that job is kind of like the part of the next thing. And it's so easy to think about like, well, I'll get this job, and I'll get this job, and I'll get to a point in my career, and then I guess I'll be able to retire, and I guess I'll just die, right? It's so easy to follow that course, but there is more. I find the best way to think about this is not like that. There was a time about 2 years ago, where I was kind of ready to pack it in. I was ready to pack it in as a developer. I was kind of like, I didn't want to do this anymore. I'd worked for companies. I had, mine's, George, what's my job? Appreciate it, thanks. Yeah, I had a kind of a number of like jobs that had just been kind of no fun and making stuff that didn't end up doing anything. And I wanted to make things to help people, and that didn't happen just because of some of the place I'd worked. So I got to the point where I was like, I don't even know if I want to do this thing anymore. And then I left one job, started searching for another one, and ended up here. And this has been a chance for me to really kind of refocus on mastering the craft. But I want to let you know, you may go through cycles of that. You may go through cycles where it's like, hey, I want this thing. And the problem with, like, this is one thing I've learned in life. The problem with getting what you want is that you only ever get what you once wanted. Things look good from the outside, and you get in them, and they are different. Maybe better, maybe worse. They are different than you expect them to be. And you don't know what that's going to be like. And what ends up happening is that the thing that you are excited about right now, that is a huge challenge, that is really just sending all the signals it can to the reward centers of your brain, in about 2 years will be boring. It'll be Tuesday, you know? It'll just be what you do. And you're going to need to then, you know, luckily coding has so many challenges that you'll always be able to, like, that's a hedonistic treadmill you can keep on going, right? Like with drugs, eventually it's just like you're ruined. But coding, there's always the next fix. There's always the next thing. So, yeah, if you get a job, you may find yourself in a job being like, this isn't what I thought it would be, therefore it's bad. It's not going to be what you thought it would be. I'm going to let you know that now. This craft is not going to be what you thought it was. Whatever it was you thought it was. So what you have to start doing is this sort of cycle of, I'm going to figure out, I'm going to do what I need to do for the work, because like people are paying me money not to learn. They may be willing to pay me the best of it, but they're paying me money because they want a product. So there's going to be a cycle of, there will be things I learn on the job, excuse me, there'll be things I learn on the job, but there's going to be things that I'm going to have to develop for myself. And I kind of want to focus on that cycle of mastering the craft and what that looks like. The point of this isn't going to be master the craft so you can get that next job. Although you may find yourself being like, I could learn about A, B, C, and people are paying $120,000 a year for C, so I will do that. Like that would make sense if it's something that kind of like aligns with your skill set, but it aligns with like your kind of where you want to go and where you feel comfortable. But yeah, the thing is that you're still going to need to start with, I'm willing to learn these things because I am interested in them, because they make me work. So I want to let you know now that your job isn't to provide you with all the opportunities you need to grow. It's going to provide you with growth opportunities that happen to align with the business model of the business that is paying you. Unless you have some sort of grant to do a sort of thing, because the government is generally speaking, the only people who will pay just money for you to be better, right? I got my education paid for through the Montgomery GI Bill. That is money to make people better, and I got some of that. Now I have to work. Any job you have is not going to provide everything you need. And so you're going to have to continue to get better. You're going to have to continue to watch your own curriculum. You're going to have to get better at that. So I want to kind of talk about that in the context of your career, but also in the context of other things you're going to be interested in. We'll end up coming back to this, I think, again on next Friday. But this is the web developer roadmap. I've been finding this to be a really good kind of sense of what to do next. And if you're going to be a web developer in 2018, these are some of the things we have. If you don't know how to do these things, you can kind of grow in these areas. There's front end, back end, DevOps. If you find yourself like, I want to get better at front end, it's kind of good to start going through this. Figure out package managers, CSS food processors, CSS framework would be great, CSS architecture. So there's a lot of stuff here. And the expectation shouldn't be, I need to become an expert in all of these to get good. Because learning skills for themselves are not actually going to help you cross that line. Knowing how to do a thing or two, like it's going to be great for itself, but if you're not using that skill, it's going to atrophy really quickly. You'll spend time learning it just to kind of forget it. What I recommend is that you start with, what would I like to be able to make? As a front-end developer, I go to places like collectui.com. And You know, here's a leaderboard. Could I implement this? What would I need to make this work? Well, I'd need to kind of design the front end. So I need to actually not design it, obviously it's already designed. I would need to figure out, I would need to make the styling happen. And then I would need to implement the logic. And then I need to probably set up a back end that actually has the information. Maybe a connection that can update it frequently enough. Maybe a socket, or maybe I just, kind of do that. So there's starting do you have what it takes to make this? If so, make it. And if you find I don't have what it takes to make it, good, you've identified what you would want to be able to do. Whenever I am looking at new skills, I always kind of have the context of, well, what is it I'd like to make? Because I can learn new skills all day long. That could be my full-time job, and I would never be done. So I really want to focus on what is it that I want to make. I realized I did all that without a split screen. So here's my split screen. A leaderboard with medals. Yeah, that's if you can figure out how to make that, then you know the pieces that you need. So yeah, my first part is start with what it is you would like to be able to make. Don't learn a skill just for itself. Let me move this over a moment. Sorry, open. You guys are May 7th. So yeah, start with what you would want to make. Start with a skill that you would like to have. If you see someone doing something and be like, I would like to be able to make that. If you have that feeling of wow, and you want to know what you would do to make that happen, do that. So find what you want to make and make it. This is convergence. Did I ever have to get about convergence and divergence and invergence? I don't know, I think it's really the last one. Convergence means I bring all the tools I have together to make something. Convergence would be, I want to make a birdhouse. I'm going to need wood, and I'm going to need a saw, and I'm going to need nails, and I'm going to need those things, right? You can also start from a skill and figure out what you could make. Divergence. Divergence looks a lot like inspiration. Right? Divergence is a lot of oh, I could do this with that, You see a blank canvas and you could paint this thing. You see a pretty bird and you think, I want to draw that pretty bird. I want to make a song that makes me feel the way this pretty bird feels. And I will find that even at your peak divergence is going to be still about 5% of your time. 5-10% of your time. It's still going to be mostly getting that, figuring out how to actually put things together. So yeah, recognize that your job won't tell you what's up. You should also have so listen to the industry. I have a Reddit with a series of subreddits, right? I have a web dev subreddit. And I get to kind of listen to, like, what are people talking about right now? Well, there's React.js, design materials. Ooh, make a collection of infographic vectors, that's handy. That's handy, right? I get to hear about what's kind of available. So now that I know that this exists, if someone's like, oh, I'd love to make a bunch of infographics for our site, how do we do that? I'd be like, well, I can already find some materials. Recompose, people are talking a lot about Recompose, which is a React functional programming library. So yeah, I use this a lot of times. I'll just kind of go in the morning and check my Reddit and just see kind of what people are saying. Like, that's all I really have to do, is just hear about like what's popping out. When something pops out about 4 or 5 times, that's when I know I should pay attention to it. The div that looks different in every browser. Interesting. So listen to the industry. You're lucky enough to work in web dev, where people are always talking about what they're doing, as opposed to other types of development, which is a little more arcane. So, yeah. Your job won't tell you what's up, and they won't. And then another thing I want to talk about is you should pull in some fundamentals. These will be things like learn to program in different paradigms. Do something of some size in C. Do something of some size in Haskell. Do something of some size in Java or C#. So when you talk to someone whose primary focus is Java or C#, you can explain to them what things are. Learn some algorithms and data structures. One thing I've been learning about algorithms and data structures is I learn an algorithm and then I figure out how can I do that in place, and how can I do that with like immutability, or how can I do that with iteration? How can I do that with recursion? Can I do it all the ways, right? So there was a thing last night where Karan Singh, who's an alum, talked about the merge sort and the quick sort. And he was very much like, okay, so I move these things, I move these things over, and I move these things over. But he was doing it where he was changing an array in place, which may actually be a better way to do it in terms of saving memory. But it's also good to know how would you do it if you had immutability. That is to say, if you had, like, I already know that I have all my, like, I don't want to change a single data structure at all. Quick sorts with an array. Well, like how would you actually do that? So it would be worth it to do let's go with data structures. Learn to implement them recursively or iteratively, and also learn to implement them either in place or with immutability. There's a reading list of books that I can kind of recommend just off the top of my head, like Clean Code by Robert C. Martin, also known as Uncle Bob. Google Uncle Bob. He gives some amazing YouTube talks about the craft. It's incredible. He's a bit of an old curmudgeon, but he's really good to listen to. I recommend again you've probably seen this or done it, but is it elegant JavaScript? Eloquent. The pragmatic programmer. Kemper wrote that one. Yeah, all these books have taught me a lot about programming itself as a craft. There's one at MIT I've been starting to read through, and man, it is like, I find myself reading through it a lot over and over again, but it is the structure and interpretation of computer programs. MIT Press. That one is free online, by the way. And if you want to get into functional code, I really recommend either Professor Frisbee's mostly adequate guide to functional programming, which is online for free, and also Learn You a Haskell for Great Good. Another one that pops up into my head, by the way, if you really wanted to like, this was a deep read, but the Annotated Turing. By Charles Spencer. Charles Spencer worked for Windows, or yeah, for Microsoft. He did a really well-known book about the Windows, like programming for the Windows kernel in C. And you know what, this camera off and it's bugging me. Did a really well-known one for the Windows kernel in C, and he wrote a book where he went line by line through Alan Turing's well-known paper on, you know, the decisions problem that kind of created the concept of computers in a lot of ways. And yeah, he goes line by line and kind of explains what's going on and what Alan Turing is getting at, which is amazing. I recommend for exercises, HackerRank, Code Wars. I've actually been doing Code Wars katas. So Code Wars has these like small programs to write called katas. I've been finding that when I sit down in the morning to code, and if my brain's not in the right place yet, I will go and do a CodeRank or do a Code Wars kata, and maybe just one or two of them just to get my head in the game. HackerRank, Code Wars, Advent of Code. This is a challenge they have. You can actually write. You can use any language you want to solve these problems, because they give you a bunch of input, and then you just have to show that you gave the right output. And they do this every year, and all the challenges from the previous years are available. There is a leaderboard you can join for Lighthouse Labs. So there's 2017 events. There's also 2016 and 2015. They're really great like challenges on like how would you solve problems. So Advent of Code, coding game. Yeah, it's worth it to kind of go through these exercises and be like, okay, how do I put this together? Things that you could look into that would be like help you understand coding better would also be so. Would be how to create programming languages. You could make your own programming language. There was a while back where a high schooler, I think, created JavaScript. JavaScript for the moon. This is JavaScript. That's a.
Did you say a high school student created?
Yeah. So it just compiles a JavaScript, but this is JavaScript. That's a comment. Such go to the moon, much doge. Very moon is false. Really dog is a doge. So this is moon is true, right? So the saying is variable moon equals false. If the dog is a doge, then moon is true, and wow is just the end of that sentence. Wow moon. Or I think, yeah, then this is a return. So please go to the moon with a doge is run the go to the moon function with a doge. Yeah, like you can just create, try it online here. So doodle, so boring as wow, var wow equals require boring. Very doge script is such messy, very doge friendly. Var doge script is such messy. So, and also this is a bigger comment, quiet, loud. Such appreciate, much thanks, wow. So you can make a language, or if this can happen, you can make a language yourself. It's so stupid, I love it. Yeah, so language design is a great way to understand what programming is, what programmers do. How great programming languages? It'd be good to kind of, I think getting better at collection wrangling. And by which I mean like, you have basically everything your week 9 interview, week 9 tech interview, get better at that. If that was a set of records in a database, you should kind of get to know how to use SQL for that. It'd be just generally good to know, given some information, how do I get the information I actually need? And how do I do that as efficiently as possible, right? Get to know your map, filter, reduce, wherever possible. Another area to look into is like, I should know about that, is parallelism and concurrency. Has anyone ever heard of Moore's Law? Ever heard of Moore's Law? So Moore's Law was an observation by a guy at IBM. And in 1965, Gordon Moore noticed the number of transistors per square inch on integrated circuits had doubled every year since their invention. Moore's Law predicts this trend will continue into the foreseeable future. The 18-month mark is now used as the current definition of Moore's Law. It's kind of slowed down. So basically what it means is if they can fit more transistors into a smaller space, that means that they can do more processing with, a chip that's like on your phone, that sort of thing, right? Which is basically a way of saying computers are getting like twice as fast every so often. The thing is that it's running out. We are starting to run up against the laws of physics. Like there's only so small you can make those. You can't make atomic transistors, right? So what ends up happening is that, I'm not saying we're the atomics point yet, but we are. They're small. So what ends up happening is that rather than making a bunch of more and more powerful microchips, we end up having like quad core. We end up having many microchips, right? So instead of having everything run efficiently in one process on one chip at one time, we end up splitting a job into many pieces and then sort of like having them all processed and then having them all come back. And that is kind of known as parallelism. Concurrency is also sort of like where you do have a situation where it's like, well, this is happening over here, this is happening over here, how do I bring them together? And then it's always kind of good to know about graphics and animation. That always seems to come up for people, where it's like, somebody will be like, that's really cool what you're doing, can you create a visualization of some sort? So this may be like you just use an off-the-shelf visualization library. But it would be good to know how, given some data, how I would visualize it on the screen. And understanding how you can update that over time. So it's always kind of good to know a little bit about graphics animation. Another big area to learn is user experience, the sort of psychology of how people use things, as well as accessibility. Okay, so this kind of covers like some stuff in the craft. There are so many more areas you can go in, and especially one of the things you can do is just find a thing and get really good at it that no one else can do. So what we're going to do now is we're going to take a coffee break, and we come back and we're going to talk about learning new frameworks and how to approach them. Okay, so we're back. Let me detach. Yeah. So new frameworks and new languages. This is going to be another big part of your life. We taught you Rails, we taught you JavaScript, Ruby and JavaScript, HTML, CSS. HTML and CSS, they're not going to be replaced by anything soon, necessarily, right? Though you may use preprocessors like different, like Jade or, like, there's HTML things like Jade that are like, let me take a look at Jade, show you what I'm talking about. Jade language. Template engine where, where you might have a structure like this that becomes this, I guess. If you're using Jade, you are amazing. Else, get on it, right? And so, or Slim is another one like this. So you may have something else that is compiling to HTML, but it's still HTML, right? That's going to stay the same. Now, on top of that, you're going to have kind of a whole bunch of stuff. You're going to have different languages. Last night I got the Work Together Friends, which is a kind of a get-together for alumni. And I was like, what should we do for the next 3 things? And they were like, Go. And I was like, fine, I'll go. I'm like, they're like, no, the Go language. Show us how to program using the Go language. And I'm like, I don't know the Go language, but let's find that out. So I think my next theme is going to be like, we're going to introduce a new language every night. We're going to do some stuff there, right? And so that's going to be part of your life. You're going to have with new languages, and even the languages you do know, but you might have some, like especially with JavaScript, there's so many variations of JavaScript, right? You might have TypeScript. You might be somewhere that has that writes in CoffeeScript. You might be somewhere that writes, we don't want you writing JSX. And you're like, but how do I write React.jsx? And they're like, well, you just write it out. And you're like, you may find yourself doing things in languages slightly different from what you're used to. Yeah.
I hear that all the time, like CoffeeScript, TypeScript, VanillaScript, JavaScript,
yeah.
And they all just like JavaScript. They all use Node to compile, to interpret, right?
So what are these? Okay, let's take a moment to actually appreciate them because So when they say vanilla JavaScript, they mean JavaScript.
Okay, yeah.
CoffeeScript is a language, and let's kind of try to look at this for a moment. Okay, alert, hello CoffeeScript, that's fine. Let's try creating a function. Let's do the factorial function because I like that, right? Factorial equals num. Then we're going to tab over.
Oh, I see.
If num.
It's another layer of abstraction, I guess.
Right, and I might even say unless num greater than 1. Else, and here I'm going to put num times factorial num minus 1. Right, and there's that whole thing. I can make this a tail recursive by just saying, hey, num aggregate equals 1. And then here I say factorial num minus 1 ag times num, right? And that ends up being that. It's a very Ruby-like syntax. What basically happened was that CoffeeScript showed up, again, just someone wanted to make languages. A guy named Jeremy Ashkenaz is also responsible for the underscore library. And basically there was a bunch of stuff he wanted in JavaScript that JavaScript was not doing for him, and the TC39 committee couldn't be bothered to get off their asses. And so he wrote CoffeeScript. He wrote in all the features he wanted. He wrote in classes, and he wrote in arrow functions, and he wrote in like the REST operator, the spread operator. Just he wrote in all the stuff he wanted. And when they met again, they were like, well, this is what people are using. Why don't we just pave the cab paths? And now we have, because of things like this and with Babel, we are able to kind of make all this work together.
Would you say that the people who go to these like DC39 meetings, would they be paid very well?
People with TC39? I don't know. I feel like a lot of them come from big companies like Microsoft, sends a bunch of people, so they'll be paid well by Microsoft to push a Microsoft agenda. But
so it's not it's by invite that you go, right? It's not like you just show up to this meeting and you say whatever you want.
I don't know. It hasn't occurred to me to show up to the TC39 committees. I think a lot of it also happens online, like where they kind of have a process. So yeah, here's CoffeeScript. Let's take a look at TypeScript. JavaScript that scales. So they say TypeScript is quick starts. Let's go to the playground.
Do you work with this ever or no?
Actually, technically I do because I use VS Code, and VS Code kind of infers types. So, in this case, so we have class greeter, we don't really want that. Let's do the functional again with that. So function factorial.
So Joe, when you meant functional programming earlier, you meant like in terms of like C, C++, like in like terms of procedural languages back then, right?
Right. Well, functional functional and procedural are very different, and I'll get to that in a second. So factorial number, and we're going to say that this should return a number as well, right? Pretty sure that's how we say that.
I think it might be an error.
Sure. So we can say that this should, and then even if we just said, hey, return num, and if we tried to say factorial hi, or hey, what it's going to tell me is, we can't do that. Hey is unassignable to a parameter of type number. Maybe it's factorial number.
No, I think you have it inside the, in there. You already have number in there.
Right.
That's a very Python thing.
Yeah, so this is now, this is how I can say, how I create something in. TypeScript is just JavaScript with more stuff, but let's get to a language that's really different. And I'm going to make another one that goes to JavaScript because I figure it's the easiest way to show things. Let's do PureScript. Hopefully they have a playground. Try PureScript. Okay. So, well, this is a bunch of stuff. Oh, the auto compile. Let's do the show.js. So yeah, this is our examples, modular export. And so all of that render is in this one big line, which I wish they had broken off into it.
You would have to install the compiler, right? And then
yeah, you have to install the compiler.
And then from there you can then use JavaScript interpreter node, I guess, right?
Yes. Let me try this though. Import prelude. What I'm going to say here is modular exports equals factorial. So this is really based on factorial is going to be number. So let me go back a second and. So yeah, these are my kind of point here is that these are really different languages. This has all that. Let me do factorial is of type where it takes in a number and it returns a number. And declaration, unexpected import, right? So let's go here. And yeah, so type declaration factorial should be followed by its definition, sure. So I might say factorial of 1 is 1. Factorial of 0 is 1. Okay, so we have, it does want int, that's right. So this is a little bit different, partial constant. And then factorial n equals n times factorial n minus 1. Right? So if I get rid of my main here, because that's the thing, doing all the work, there's my factorial. If b equals 1, return 1. If b equals 0, return 0. Otherwise, return b factorial, b minus 1 or 0, 0. And it's pushing it into ints. That or 0 thing here is making sure it's an int, an integer. But this is a really different way of writing code, right? What's actually happening here? Well, this is, PureScript is kind of based on Haskell in the browser. And what it's saying here is, the type for factorial is I take an int and I give out an int, right? And I might be able to do, I think they can do a thing here. So what this is saying is, hey, when the int is 1, just return 1. If it's 0, just return 1. For everything else, return factorial n equals n times factorial n minus 1. And yeah, this is saying, oh, in this case, do this. So there's a pattern matching. And this is a really different way of thinking about your codes, right? So you're going to find yourself in different languages, and you have to, with all of them, figure out what is their opinion, how they want you to set things up, what their functions are, and what you're going to find going from language to language. And I kind of like JavaScript as a starter language because JavaScript is just so dirty. It's like a procedural program that has like a little bit of a bunch of stuff. So it has so few opinions, and you'll be like, whenever you get to a language, you're going to have to learn its stuff already because JavaScript is so weird. And so what ends up happening is that when you get to another language, you'll be able to be like, okay, I will learn their type system and that sort of thing. So what is their opinion on? So they might have their opinion on things like control flow. So in PureScript, where did I go with that? They kind of want me to do things more iteratively. It's really hard to do like a for loop. Or so they want me to do things recursively. It's hard to do a for loop in this. Let me actually do a factorial int factorial tail recursive here. trn aggregate equals if n is less than 2, return 1. I guess otherwise? No, otherwise what it is. Otherwise I'm going to return factorial tr n minus 1 egg times n. And you'll see it does a whole bunch of other stuff here. Specifically, you'll see the word TCO, tail call optimization. So it recognizes this tail call recursive, and it's going to make this thing happen. You'll also notice that this is int. And what's happening is that factorial tr of I'm gonna rephrase this real quick, where my factorial, I'm going to say that it's factorial of n is now factorial tr n 1. And what this is saying is, yeah, this one is now like, it's able to do the tail call recursion, and it's kind of hard to explain what's going on here. But one thing to notice is that if I just put in a number, it would give me a new function to which I could put in another number, and then it would actually give me the result. And this is going to prepare on flow. They'll have opinions about immutability, whether you should change things or not. They'll have opinions on like structure and typing, and you're going to have to get used to the fact that like every language is going to have its own thing about this. So what I recommend as a result, watch YouTube tutorials / read tutorials, all that. That's a big part. But also try to recreate code you understand in that language. There is a YouTube from Coding Tech, Coding Tech 4 Paradigms, where a woman does the same program, the coin counter, 4 times in 4 radically different types of code. And it's kind of cool to see, like, here's this code, but here's how different languages take different stabs at it. Yeah. Yeah. Word paradigms. So you may find yourself in a language that is just totally different. And what I recommend in that case, who's seen Doctor Strange? Who's seen Doctor Strange movie? There's this one scene in Doctor Strange where the Ancient One says, talks about like it's a river, and you can't fight the river, you have to kind of give yourself into it. And he's like, how do you control something? So you control something by giving up control. That doesn't make sense. She's like, not everything has to make sense. So if you find yourself in another language, it is going to, you have to kind of take some time and like really get into how they think you should structure their code. And what I would say, when you do that, don't evaluate that approach for whether it's right or wrong or good or bad. If you're dealing with a language that's a good use, it's been of use to somebody to make something, right? If you find yourself using Python for the first time, Python may seem confusing, but it has been of use to somebody for something, for many things. Like there's a whole subset of people who like the only programming they do is they do Python stuff for like science and data stuff. And there's a lot of people for whom Python is the go-to for some good reason. There's some people for whom Python is their language. When the advent of code came last year, Jeremy Holman and I were always going, and his language of choice was Python, and my language of choice was JavaScript. And we just kind of went through that. So you're going to have to kind of give yourself over to how they say you should structure your code. Don't try to structure their code in your paradigm immediately. Try doing it in theirs, and also try to learn from how they are saying to structure their code. Learn from how it's different from yours. Try to figure out why they. At the end of the day, everything we do is abstractions on top of procedural code, right? So it's good to sort of get used to that.
Wait, you say you would explain the difference between functional and.
Right, functional procedural.
No,
So.
Sorry, JavaScript. What would you say? It's a prototype language, or?
Okay, so JavaScript is really a procedural language that happens to have like 20% of the features of a functional language, so you can do 80% of the functional programming, and 20% of the features of an object-oriented language, so you can do 80% of object-oriented programming. So with paradigms, and again, if you watch this video, they're going to show you the 4 paradigms. Procedural is everything is just a list of commands. You kind of start at the top and you go to the bottom, right? With OO, everything is an object. So you constrain all the behavior of your app into objects in a hierarchy, right? It really uses the three pillars of there's inheritance, which is if A has behavior that I like with some tweaks, I can make a class B that keeps stuff from A but makes changes. Right? So I can if I have this thing, I can create a specialized version of it for my needs. And inheritance is all about like getting the behavior shared between things. There is polymorphism, right? Which is that if somebody wants a parrot, you better give them a parrot. But if somebody wants a bird, you can give them a parrot or a parakeet or an eagle or whatever, right? So one thing has different categories it belongs to. So a parrot is a bird, and it's also an animal, and it's also a flyer, right? Like it might implement the flying interface, which is not a strict category on its own, but like it belongs to these things that have this behavior. So certain categories it belongs to. And the last thing is.
So, sorry, is that one thing like it's a parrot? Like parrot?
Yeah.
Because it belongs to different
Right. So like yeah. So there's one parrot. So let's say we have, for instance, and I'm going to write this kind of in C# for a moment, but I might have CS. I might have class parrot extends, but not extends. It's
you can use the like a function example that displays polymorphism, right? So like if you have a function that takes in like a for loop,
right.
Then it can have many different outputs depending what your integer that you put in, right?
So like if I create a parrot class and I have parrot poly equals new parrot, then if I have a function that is not a function, not really a function. So if I have a class some other class that has like a static void, or sorry, a public static void do thing with parrot, and it's going to expect a parrot, right? Now I don't know what this does, but I do know that I can give them poly. Same thing with if I have a method public static void do thing with bird, I can give them poly, because poly is a bird, right? And if I have public static void make something fly, that implements the iFly interface. So it's just basically like a bat is not a bird, right? But a bat flies. So there may be things in other hierarchies, and also a penguin is a bird, but a penguin doesn't fly. So I may be able to make, like this has the flying behavior, this has the flying behavior. Just letting you know these things are the flying behavior. So I might say iFly flyer, and also poly can go in these, because poly is polymorphic. I've been leading up to that joke for like 5 minutes. It's polymorphic. Right. So Polly is going to fulfill all the expectations I would have of a bird. Polly is going to fulfill all the expectations I would have of a parrot. Polly is going to fulfill all the expectations. I might have an interface. Interface I fly. That just says like, hey, there should be void fly. And all it says is like, hey, you should have void fly, right? So that's polymorphism. And then encapsulation is I cannot see what's wrong here. Encapsulation is I cannot see the basically an object can store state that no other object can change without its permission, or without its permission, right? So it's basically like this thing will have some information, and you can say like, okay, move that thing over by this much, and I'll be like, yeah, I can move it over, if that's a permission I've made available. That's encapsulation. So with functional, everything is a pure function. And it's pure, and that means it is deterministic, always the same. It has no side effects.
So no console logging?
No console logs, no database, no updating the screen, nothing, none of that, right? And but the thing is, and so basically like you should be able to replace this with its product, right? Or you should be able to run this function and replace the running of it with just the results of it. So then that's what's called, there's a word for it that's now popped out of my head. It's like referential transparency. Referentially transparent means like math.square root 4, you could have math.square root 4 in an expression, or you could just put 2 there and it would make no difference, right? That's referential transparency. Which means that technically speaking, in the truth of a functional program, it can't do anything. It is a useless program.
Wasn't that just procedural? Like, but the other.
Okay, there's a big difference. No, the difference with procedural is that it's all side effects,
exactly.
right, all the time. So the procedural is all pretty much like everything, you do a thing, you do a thing, you do a thing. It's a list of things to do. Not every line, like obviously you need something like math.square root. You can have pure functions, but the assumption is like we're just doing things over and over again. So with functional, you have to do some kind of clever, basically you end up taking all of that dirty, all of that console logging, all of that randomness, all that everything, and just sort of putting it in very specific parts. So it's not really getting rid of that stuff. It's more that you push all that stuff to the edges so that your logic is pure. The logic, the running of your app is pure. So basically, if you had a deck of cards, or sorry, if you had a game of solitaire, for instance, and it had like, here's all the things, here's all the random, here's all my decks, and someone wants to make a move from here to here, you can have a function that's like, okay, you can't do that for these reasons. You might have a function that's like, people are moving their mouse over the thing like this. I'm going to take that. That's a random thing. That's random. It's always changing. It's never really static. I'm going to take that dirtiness and I'm going to translate it into a different kind of dirtiness, which is the thing. Kind of like I can take one promise, another promise, and kind of like put them into this other eventual promise. And so, yeah, so really what happens is we push the dirty stuff to the edges and abstract them away from our app logic.
Does this run from top to bottom? Like
it doesn't. Well, I mean, everything has to have an entry point. That's the thing. Everything has. But the thing is, it's like the idea is that you kind of don't. You don't have things. So let me give you an example of awk versus, there was a thing, Haskell versus, Haskell DOD, Proto, not DOD, it was ARPA. There it is. Haskell versus Adam versus C++, blah, blah, blah. So this is a really terrible named paper. But basically what happened was, again, the idea was that the Advanced Research Projects Agency, now known as the Defense Advanced Research Projects Agency in the United States, is the, they were paying a lot of money for people to make software, right? And they decided that Haskell wasn't good, this functional programming. But then they decided, like, okay, you know, maybe it's great for software prototyping. So they had this one problem, and they had this one problem of like, here's this GeoServer input data. It's kind of geographical, and we have all these regions. And what I want you to do is, I want you, given this data, I want you to figure out what, like, where things are and how that works, right? And so the people who are doing this in C++, they were like, okay, we have these regions, everything is a thing. We have to make classes for everything. Everything is a thing. We have to think about what things are in terms of things, right? And it was, the idea was that if there's anything kind of in the way of stuff, you know, in commercial aircraft, in tight zone hostile craft, it was mostly trying to figure out, like, okay, is this thing in this region? And so the Haskell guys, for them, when they wanted to describe what anything was or did, it was like, well, technically speaking, a region is only a, it's basically a function that takes in a point and returns a Boolean. Right? Like, that's all I really need to describe a shape. I need to describe, is it in this area? Okay, that seems simple enough. So what they would do is they would like, okay, so if that's the case, then a circle, to describe a circle, how would you describe that? Well, it's just basically I put in a radius to start with, and then I put in the x and y of the point, and I put in a center, a radius, and then an x and y and a point, right? So let me kind of bring up pure script here. And what I'd say is, so if an area is a definition of maybe int x and int y is, and it's going to return you a Boolean. That makes sense, right? That's what any area is going to do. It's going to take an int and return you a Boolean. So then work that out. So then a circle, well, that's going to take in an int x and an int y, or maybe a float. Let's do floats. A float and a float and a float for radius, right? So that's the circle, my description of the circle. And so then I'm going to say, well, a float and a float will be a Boolean. And basically what I'm going to say is, okay, so circle is going to be cx, cy, radius, x, y. And what I basically want to say is it math.square root, I wonder? It's basically the square root of, like, I'm going to find the difference between these two. So maybe I'm going to create a difference that's going to be a float, 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 Boolean. And I might just say, like, actually, I don't know. I can define a position thing, but yeah, I'm going to say diff is square root. You know, I know how to find the difference between 2 points. So let's just pretend that I had done this part here. This is not returning float, it returns float. So I'm going to say diff, but right now I'm just going to say diff equals 1, just because. And I'm going to say here that this is true if the diff of cx, cy, x, and y is less than r. Unknown type floats. No? Perfect. Okay, cool. Right? That seems to make sense. Just. All right. Well, how would I create a not in? Well, I would take an area which takes in number Boolean, and then a number and a number, Boolean. And I would basically say not in area x, y equals kind of not of area x, y.
Do functional programming languages also like start from the top, and or like does
They
it
don't really kind of start from the top. Right now what I'm doing is I'm basically creating a bunch of function definitions. And then what you can do is create a main method, and you'll usually find a main method and do something like that. So now we have our diff, we have our circle. You know, here's a function, returns function, returns function, returns function, returns function. Equals, is it? Hold on. Pure script not. Negate not. Right, so that should be it breaks me in. Oh, not x. Makes sense. So I'm going to say equals not, right? And then I might say, okay, well, how do I define a ring? How do I define that it is in this ring? But not in this circle and not in this thing. Well, I would just basically be like, ring would be, we know eventually it wants to put out something of this type, right? So I would say that ring is, well, I'm going to take in a number for the center. I'm going to take in a large radius for the entire thing, and I'm going to take in a smaller radius, and then so my ring is going to be a ring cx, cy, outer radius, inner radius, xy is equal to, well, it has to be within the big circle. Circle cx, cy, outer ring. And I can kind of end this here. It's now saying, oh, cannot match type number Boolean with Boolean, which is fine. And maybe I have to put this here. And not, or and not in circle cx cy ir. Unknown value and oh, I just use and. Cool, cool, cool. And so this, I actually don't even need this xy here. And this compiles, right? So it is basically, I define the logic of what it means for something to be in a ring like this. I know what that means. You'll notice I didn't even have to say xy because like, well, all of this is returning a function that will take an x and y and a boolean, so we're good. There's also a strict typing here.
Isn't that just classes, but you're defining functions instead?
But they're not classes because they don't have.
Yeah, they don't.
So that's the thing is they have to kind of like this is an example of like stuff to learn is that you start to relieve yourself of like types equals classes. Types doesn't equal classes, and in fact all of your types here are going to be functions. Are going to be like some basics. You can make some object types, but for the most part you're going to get this.
Yeah, so then you would just define a list of functions and then invoke them, right? And then that'll run from all the way down.
Yeah, and so basically what happens is that you create a main, like once you define all your app logic, you end up creating a main function. And then it's like, okay, I'm going to get this stuff in from like the process standard out or something like that. I'm going to get these things in from the input. I'm going to take these things in, and then I'm going to perform like all of my connections. But all of your app logic is done like this. What ended up happening with that one paper, by the way, is that they made a list of who was able to like. They made a list of all the development time and lines of code that were created. And Haskell came in with 85 lines of code, 465 lines of documentation, and 10 hours of dev time, as opposed to the Ada and the C++ and the awk and knock and repeat and a few of the other ones, right? And someone went over the 85 lines of code and realized that all the type signatures were actually unnecessary, and realized actually we didn't even need, like, this could have been taken down to like 50 lines of code, which still took C++ 1,100 lines of code. And so it's basically, once you get used to the functional style, it's mostly, hey, I'm going to think of, like, even if you think of like people typing, you can think of the typing as you're getting in all these keyboard events, but you can map those to like, I don't really care about the keyboard event, I really care about the letter coming in, and then I'll do something with that. Or I care about the state of the text. So I'm just going to get a stream of what the state of that text is now. And yeah, you start to kind of organize yourself that way.
Wait, so you're saying that there's one function that triggers all the other functions, I guess, right?
Yeah, but that's technically true of every single program.
That's true, yeah. And then in procedural, it would just execute from top to bottom. Like, it doesn't know how to communicate from here to here to this.
I think most languages assume that you're going to use, if you have an int main, that's the thing, or Java public static void main.
Yeah.
So there is always an entry point.
Okay.
This was a tangent. I'm sorry, we had a tangent. Frameworks are going to be much the same. New frameworks are going to be much the same because it's like you're going to have to deal with their way of doing things. I find that with server frameworks, there's always sort of a how do I handle a route? How do I create a template from some data? And there's always some how do I talk to a data source. So you're going to figure out how to do these three things. Oh, and generally speaking also, how do I know who this is? So sessions, cookies, that sort of thing. With front ends, there's basically two big things. How do I keep track of state? how do I represent that state? How do I get messages from the user to change state? Those are your three big problems. Yeah, so you're going to be confronted with new frameworks all the time. It's good to sort of look through, like, if you know what you are looking for, and I think that doing Express and Rails helps you figure that out. What you can do is get used to, oh, I just need to go to this. I know where I just need to find where my entry point is. How do I make an HTTP request? What code handles that? How do I talk to my backend? How do I talk to my database? How do I talk to how do I know who the server is? How do I send other stuff? And that's going to be true regardless of the language, regardless of the prototype, or the whatever. So yeah, I know the functional part's a bit of a tangent, but I think the part about functional programming to think of is that everything is, I put in an A and I get a B. Not I put in an A and I do things. So with procedural, everything is an instruction. With functional, everything should be an expression, right? It's less about what I'm telling you to do, and it's more about telling you what I want to get back. Instead of me saying, you know, crack the eggs, do this, do that, do this, I'm more like, given eggs and flour and stuff like that, this is how the cake comes together. It's this plus some heat and then plus some time. Whereas it's like with instructional, it's always like break the egg and then with that, like while, like, you know, you do a for loop over 4 eggs, right? And break each one, add it to the batter, that sort of thing. And this is more like, I'm going to map every egg to a broken egg, and I'm going to reduce those into a bowl, right? So what you end up with isn't, I can tell you how to turn 4 eggs into a bowl of eggs, right? And that's more the difference. And then how to turn that bowl of eggs into, like, you know, everything else. And how to combine them. Like, it's more about the combination, like, okay, good, then you have a batter. And now we need to do something with the batter. We need to actually put that in the thing. But it's more about, like, what you have at each stage, more than the steps it took to get that, if that makes sense. So that's the difference between functional and procedural. I know, there's also other paradigms. Yeah. What else happens? Yeah, so this is, I guess my point in this is knowing that you do know enough to, like, program anything. Technically speaking, as soon as you know how to assign a variable and do an if or a while, you knew everything you needed to do to program every program ever. It would just take you a while. That'd be like me saying, like, I gave you a pocket knife and a hammer and you could build every house. That is technically true. It would just take you a while, and that house would be shaky. So everything you learn is going to be an abstraction on that. Everything you learn is just taking that basic concept of, like, I start at the top and I go to the bottom, and becoming something else. So I recommend, yeah, I especially recommend kind of getting used to, like, doing some things in object-oriented and doing some things in functional. They're the two kind of competing paradigms, and they have such different aims with each other. And they will show you the importance that you'll be doing functional and be like, well, this part is awesome and this part sucks, and you'll be doing object-oriented and be like, oh, it's backwards now. This part that did suck in functional is awesome now, and this part that was awesome in functional doesn't work here at all. And it's good to kind of get used to that. So, yeah. Good luck on your projects. I look forward to seeing your demos. If you have questions, let me know. And yeah, it's been fun. It's been real.
Thanks, Joel. Thanks, Joel.